First off, Dynamic Host Configuration Protocol. What DHCP does for us is it allows an administrator who's knowledgeable in how networks should be configured to set up a service on a device that will automatically hand out the correct IP configuration information to the workstations. So far, if you've been watching these courses in order, you've seen quite a bit of information, and we've learned quite a bit about all the little pieces and details that makes a network work. If we need that much education to understand how a network works, we should not rely upon our end users to configure their own IP addresses. So we set up this DHCP server, and remember, a server is a service. It can run on any device. In this case, I'm just showing you that the server is running on some box that's connected onto our network someplace. We can just as easily configure our router to behave as a DHCP server. Do we have to configure the router as a DHCP server? No, we do not. The router can be one, but it does not have to be one. It's just an extra feature that we can put on the router. Since this course in this series is learning about Cisco routing and Cisco networking and configuring Cisco routers, we're going to set up that DHCP server right on our router and not in Windows or Linux. Now, if you're taking a Windows course and you're learning about Windows Server, you're going to learn to set up DHCP on a Windows server. Both are going to accomplish the same purpose. When we configure our workstation, then, we're going to set our workstation to obtain an IP address automatically, and as well as obtain our DNS information automatically. When we select this automatic address configuration, what we're doing is we're enabling the DHCP client to operate on our workstation. So what happens then is when our client comes online onto the network and the workstation is configured to use DHCP to acquire an address, the workstation will come online and send a message out, a DHCP discover message, sends it out as a broadcast to everybody on the network. Everybody sees that message and eventually makes it to our DHCP server. Our DHCP server then will see that discover message, and what it does then is it creates something called a DHCP offer. What it does is it looks up in the configuration of the server, finds out what address is available to hand out to the workstation, and then it's going to hand to the workstation the IP address, the subnet mask, the default gateway, and the DNS server. So now the workstation has this offer, this DHCP offer. So the workstation now is going to respond to that offer, and it's going to respond with a DHCP request. So now the request that it sends to the DHCP server is going to say, hey, I got your offer of 10.0.0.100/24. I am going to now request that address of you. And then what the DHCP server will do is it will then follow up with an ACK, a DHCP acknowledgement, and it forwards that acknowledgement on to the workstation. And now the workstation will have configured the IP address 10.0.0.100 with the 24-bit subnet mask, the default gateway 10.0.0.1, and our DNS server out at Google. In that whole process, the DHCP server is going to create a DHCP binding. And what it's going to do is it's going to take that address that it assigned to the workstation that requested it, and it's going to create a table. And in that table, we're going to take the MAC address of the device, and we're going to associate it with the DHCP information we sent to that workstation. So now our DHCP server has a list of the addresses that it's handed out. It knows what MAC addresses belong to which IP address. The whole purpose of that is so that our DHCP server does not duplicate addresses as it hands them out. So now it knows that the workstation with the MAC address of A is always at 10.0.0.100. And then when the other workstations send out their DHCP discover message, the DHCP server will not hand out anymore 10.0.0.100. It'll hand out some other address.